Why is the Great Attractor pulling entire galaxies? For centuries, humanity believed the stars were fixed, tiny points of light decorating an unchanging sky. Then astronomy revealed a much stranger reality. The Earth is moving, the planets are moving, the Sun is moving, even the Milky Way is racing through space. Nothing in the universe is truly standing still. But there is one motion that continues to puzzle astronomers more than almost any other. Our entire galaxy is traveling towards something we cannot see, not slowly, not gently, but at nearly 600 kilometers every second. That is more than 2 million kilometers every hour. At that incredible speed, you could travel from Earth to the Moon in just over 10 minutes. Yet despite moving so quickly, we feel absolutely nothing. Gravity keeps everything around us moving together. The Earth, the Sun, the Milky Way, our neighboring galaxies, all drifting through the universe as part of the same enormous journey. The destination is known as the Great Attractor, one of the largest and most mysterious gravitational regions ever discovered. Unlike a planet or a star, the Great Attractor is not a single object. It is a vast region of space where unimaginable amounts of matter are concentrated. Its gravity influences galaxies hundreds of millions of light-years away, including our own. The mystery first emerged during the second half of the 20th century. Astronomers were carefully measuring the motion of galaxies throughout the nearby universe. According to the expansion discovered by Edwin Hubble, every distant galaxy should appear to move away as space itself expands. The farther away a galaxy is, the faster it should recede. That prediction works remarkably well on the largest scales. But precise observations revealed something unexpected. Many galaxies possessed an additional motion, a motion that could not be explained by cosmic expansion alone. Astronomers call this extra movement a peculiar velocity. Unlike expansion, which affects space everywhere, peculiar velocity is caused by gravity. When enough galaxies were measured, an extraordinary pattern emerged. Entire galaxy clusters were drifting in nearly the same direction. Independent galaxies, massive clusters, even our own local group, all appeared to share the same destination. It was as though an invisible current were carrying entire islands of stars across the cosmic ocean. Imagine floating in a calm sea. You cannot see the current beneath the surface, but every nearby boat slowly begins drifting the same way. Eventually you realize something powerful is moving the water itself. That was exactly what astronomers observed among galaxies. Something enormous was pulling them together. The obvious explanation was gravity. Gravity never switches off. Every object with mass attracts every other object. The larger the mass, the stronger the attraction. The Moon circles Earth because of gravity. The planets orbit the Sun because of gravity. Stars remain inside galaxies because of gravity. Galaxies themselves gather into clusters because of gravity. So if hundreds of thousands of galaxies are moving toward the same region, that region must contain an extraordinary amount of mass. But there was a problem. No telescope could clearly see what was there. The direction of the Great Attractor lies behind one of the most difficult parts of the night sky to observe. Our own galaxy blocks the view. The Milky Way contains hundreds of billions of stars, immense clouds of gas, dark lanes of cosmic dust. Together, they create a natural barrier known as the Zone of Avoidance. It is not empty space, it is simply hidden. Looking through it, using ordinary visible light, is like trying to observe a distant city through a dense forest during a heavy fog. Something may exist beyond the trees, but almost everything is concealed. For years, astronomers could only estimate what might be hidden behind this cosmic curtain. Then, technology improved. Infrared telescopes could detect heat that passed through much of the dust. Radio telescopes mapped hydrogen gas hidden behind the Milky Way. Powerful X-ray observatories located enormous clusters of galaxies filled with superheated gas. Little by little, the invisible universe began to reveal itself. Researchers discovered giant galaxy clusters occupying regions that had previously appeared empty. One of the largest became known as the Norma cluster, containing hundreds of galaxies packed into an enormous gravitational system. At first, many scientists believed they had finally located the source of the Great Attractor, but the numbers refused to cooperate. Although the Norma cluster was incredibly massive, it still did not contain enough gravity to explain everything astronomers were observing. Our galaxy was moving too quickly. Too many neighboring galaxies shared the same motion. The gravitational pull seemed larger than the visible matter could produce. This problem sounded strangely familiar. Astronomers had encountered it before. When studying the rotation of galaxies, they discovered stars moved far faster than visible matter alone could explain. Galaxies should have flown apart. Instead, they remained stable. Something invisible appeared to provide additional gravity. Scientists called this mysterious substance dark matter, not because it is black, but because it neither emits nor reflects light. It cannot be seen directly. Yet its gravitational influence shapes galaxies across the universe. Today, researchers estimate that ordinary matter, the stars, planets, gas, and everything we can see, makes up only about 5% of the universe. Dark matter accounts for roughly 27%. The remaining 68% is believed to be dark energy, the mysterious force driving the accelerated expansion of the universe. That means nearly 95% of the cosmos consists of things we still cannot directly observe. The Great Attractor may be one of the clearest reminders of just how much remains hidden. Perhaps what pulls us forward is not a single object, but an immense web of visible galaxies embedded within an even larger network of invisible dark matter, a cosmic framework stretching across hundreds of millions of light-years. If that is true, then the Milky Way is not simply traveling through empty space. It is flowing along one strand of an unimaginably vast gravitational web. And that web may lead somewhere even more extraordinary than the Great Attractor itself. For many years, astronomers imagined the Great Attractor as the final destination, the ultimate source of the mysterious pull affecting our galaxy. But as telescopes became more powerful and computers processed ever larger maps of the universe, something even stranger began to emerge. The Great Attractor was not alone. It appeared to be moving as well. Just like the Milky Way, just like countless other galaxies, the Hunter was also being pulled. To understand why, we have to zoom out farther than ever before. A single galaxy is enormous. The Milky Way contains between 100 and 400 billion stars. Yet galaxies rarely exist in isolation. Gravity gathers them into groups. Groups merge into clusters. Clusters connect to form superclusters. And those superclusters are linked together by immense filaments of galaxies stretching across hundreds of millions of light-years. Together, they create what scientists call the asterisk cosmic web knot. If we could step outside the observable universe and look back, the largest structures would not resemble scattered islands. They would look more like a giant three-dimensional network. Brilliant strands filled with galaxies, separated by enormous cosmic voids where almost nothing exists. It is one of the most beautiful structures ever revealed by science. And it is almost entirely shaped by gravity. In 2014, astronomers studying galaxy motions reached another remarkable conclusion. Our Milky Way belongs to a previously unrecognized supercluster containing more than 100,000 galaxies. They named it asterisk Laniakea, a Hawaiian word meaning immeasurable heaven. The name could hardly be more appropriate. Laniakea spans more than 500 million light-years. Inside this colossal structure, galaxies flow along gravitational pathways, much like rainwater flowing into rivers. Every galaxy follows the pull of surrounding mass. Slowly, patiently, over billions of years. The Great Attractor lies near the gravitational center of this enormous flow. But even Laniakea is not isolated. Far beyond it lies one of the most massive concentrations of galaxies ever discovered. The asterisk Shapley supercluster, containing dozens of rich galaxy clusters and an extraordinary amount of matter. Many astronomers now believe that part of the motion once attributed entirely to the Great Attractor is actually influenced by the combined gravity of the Shapley supercluster. In other words, our galaxy is responding not to one giant object, but to the combined gravitational influence of unimaginably large cosmic structures. The deeper scientists looked, the larger the picture became. This is one of astronomy's greatest lessons. Every answer reveals an even bigger question. Yet gravity alone does not explain everything. Remember dark matter. Although invisible, dark matter outweighs ordinary matter by roughly 5 to 1. Its gravity binds galaxies together, guides the formation of galaxy clusters, shapes the cosmic web itself. Without dark matter, computer simulations show that galaxies like our own might never have formed. The universe would look completely different. But here lies the greatest mystery. After decades of searching, no laboratory has directly detected a single dark matter particle. We observe its effects everywhere, yet we still do not know exactly what it is. Some theories suggest entirely new particles beyond the standard model of physics. Others propose modifications to gravity itself. So far, every possibility remains under investigation. The Great Attractor reminds us that the universe is filled with invisible influences. Not magic, not supernatural forces, but natural phenomena we have not yet fully understood. Perhaps future generations will look back on dark matter the same way we now look back on electricity before it was explained. Always present, always shaping the world, simply waiting to be understood. Fortunately, new observatories promise to bring us closer than ever before. The Vera C. Rubin Observatory will map billions of galaxies with unprecedented precision. The Euclid Space Telescope is already studying how dark matter and dark energy shape the large-scale structure of the universe. Future radio telescopes, including the Square Kilometer Array, will observe enormous regions of space hidden from previous generations of astronomers. Each mission adds another piece to an extraordinary cosmic puzzle. Perhaps one day we will map the invisible matter surrounding every galaxy. Perhaps we will discover entirely new forms of physics. Or perhaps the universe still holds surprises beyond anything we have imagined. One fact, however, is already certain. The Milky Way is not drifting aimlessly through empty space. It is part of an immense gravitational journey spanning hundreds of millions of light years. Every star in our night sky, including our own sun, is quietly participating in that voyage. Even as you listen to these words, our galaxy continues, moving toward a destination we cannot yet fully explain. The journey is so slow that it will take billions of years. Long before we arrive, the universe itself will continue evolving. Galaxies will merge, stars will be born, others will fade away. Civilizations may rise and disappear, yet gravity will remain, patiently shaping the architecture of the cosmos. Perhaps that is the true wonder of the Great Attractor. It is not merely an astronomical mystery. It is a reminder of how small we are and how connected we are. Every atom in your body belongs to a planet orbiting a star. That star belongs to a galaxy. That galaxy belongs to a supercluster. And that supercluster is part of a vast cosmic web stretching across the observable universe. We often imagine ourselves standing still beneath the night sky. The reality is far more extraordinary. We have been traveling through the universe our entire lives. We simply never noticed. And somewhere beyond the stars we can see, gravity continues guiding that endless journey toward mysteries that humanity has only just begun to understand.